This is Unevenly Distributed, a podcast from Nexavize.com, where we talk to experts to find out what's next in digital technology and where it's real today.
This is Unevenly Distributed, a future tech podcast, and I'm Jeff Ilimek. Today I'm joined by an expert in AI, a data and AI lead at Avanade, Six Khatiwada. Six, welcome.
Awesome. Thank you for having me, Jeff.
Thanks for being here. You're one of my favorite people to talk to at Avanade about anything, but about AI in particular. And I know pretty much what you do, but with any innovation kind of role, I know it's hard for all of us to describe what we do, but I'm going to put you on the spot and say, why don't you briefly describe your role and what you do, and we'll go from there and we'll get into some fun things.
Absolutely. So Jeff, at a high level, we have about 75 people that specifically focus on data and AI solutions. So what that means is everything from data platform modernization to Power BI at scale, data visualization at scale, to doing a lot of really cool predictive analytics work and AI IoT work. All of that really fits underneath that portfolio. I think this might be a very relevant example, actually. A current project that we're working on for a large company is around building their digital twin. So what a digital twin is, it's a replica. It's a digital replica of a physical object. So we're looking at their factory, their production plants. And then with all of the IoT sensors, we're detecting the heartbeat of all of the machinery in there. So as they're building, manufacturing different types of products, we are very aware of what type of machinery they're using, whether or not the machinery needs any sort of support, if the machinery is going to be out of commission soon, and really doing some predictive analytics on top of that. And it gives us the ability to be able to save hundreds and thousands of dollars for our client, because we know just by looking at the heartbeat whether or not the machinery is executing to the highest level of its performance.
I love digital twins, but the important part of that intro, which I wanted people to understand, is you work in solving real problems out there with real clients and putting this stuff to work, which I think is super exciting. On the digital twin side, and you think about artificial intelligence and machine learning, a lot of it is really focused right now, especially on the predictive side of things. It's, hey, can I watch all of this data? Can I put it into a digital model that mirrors the real world enough? And then can I start using that digital model to predict things? And then the trend in the last couple of years has moved from beyond predictive to prescriptive. And I think that's when things get really exciting as well. I think I'm going to have to do a whole new episode. Maybe we'll bring in just to talk about digital twins, because that's a fun thing.
Fun stuff.
But there, we described a couple of ways that AI is being used to solve a problem. Why don't we go through a little bit more of that? We're not going to do a whole deep dive into what AI is as much, but predicting things, deciding what you should do next about things. There's AI models that are cognitive, which I like to play with. Those are the most fun. This is the picture recognition and facial recognition. And then again, they get into the building on that, creating new things, like DALL-E is creating all these new fun images for us. But why don't you describe, just for people that aren't all that familiar, because I think this will underpin when we start talking about sustainability, which is the great foundation for the future talks about AI. How do we do this the right way for the future? But what does it take to build a machine learning model to make that model? What's actually going on there?
I mean, I would just provide the most simplistic example. Like for us humans, when we look at a picture of a cat or a picture of a dog, it's fairly easy for us to say, this is a dog and this is a cat. For a machine to be able to identify what a dog looks like or what a cat looks like, you have to feed thousands and thousands of images and actually teach the system or the algorithm what the features of a cat or a dog is, and then it learns from those patterns. So for us, it might be a simple process that happens where we can identify a dog right away. But for a machine and a machine learning algorithm to really identify that, it takes hundreds, if not thousands and millions and billions of data points to be able to understand that pattern and actually recognize that pattern to be a dog.
that idea of these huge data sets with hundreds to thousands to millions of images, like when Microsoft put their facial recognition model together, I know they used millions of images. First to say, what's a face? And then there's layers that go on top of it to say, okay, now recognize individual faces. But at the lowest level, it's a bunch of math. There's linear algebra. There's these big, you could think of it as like a big spreadsheet. If people can envision a spreadsheet with a number in each of the cells of the spreadsheet. But now it's not just a two-dimensional spreadsheet. It's 3 or 4 or 5 dimensions of a spreadsheet. And you give it an image and it puts a bunch of numbers in those cells. And then you give it another image and it adjusts all those numbers. And there's a bunch of math going on. And the math gets run on these processors. And when you do, you run the math to adjust all of those numbers in this multi-dimensional array a million times, it can take a long time and a lot of compute on a lot of processors running in some big lab somewhere to make that model. What's the biggest model that you've had your fingers in? Like, how long has it taken to generate even a moderate, one of a moderate model, not like the million picture models?
Fortunately for experiments that we run with our clients, we're not doing extremely intensive math. A lot of times because the use cases are not very extensive. So from a business perspective, right, it is very important for a client to be able to do some financial forecasting based on some, historical data. And that is like good enough. It doesn't have to be orders of magnitude better than the competition. We're not looking at models to be the most efficient, most accurate models. We're looking them for to be useful enough that a business problem can be solved. But as you start to get into like LiDAR technologies and when you start to get into, autonomous driving cars, that accuracy is absolutely important because that could be the difference between the car identifying something as a human or just an object on the road.
And we working in engineering on AI and machine learning, we get to take baseline models and do things on top of them. Mm-hmm. We get to take baseline AI and machine learning and predictive analytics technology, like stuff that's built into Power BI, and do stuff on top of it.
Yeah.
The creation of the underlying models, that's a separate process. So we've played with facial recognition quite a bit for different things for different clients, but we grabbed Microsoft's model. We didn't have to redo what they did. But there's still when you put the baseline face set in there, there's churning and processing that go on. And then when you start getting these more complex models, there's churning and processing that goes on. Yeah. A lot of that happens in cloud data centers, right? You're just paying for the compute cycles. Right. And it can. I mean, like the huge data sets can take days on like a huge, like a supercomputer days worth of running. And that translates into what? That translates into power usage. Exactly. So this is where we get to sustainability, right? Yeah. So let's talk a little bit about sustainability, sustainable computing, where that's at, and what the challenges are, what the problems are, why we're starting to think really hard about it right now, because it's becoming more and more of a problem, right? So where is that at?
I will say in US, we are probably at our infancy. Europe has definitely been very forward when it comes to carbon. So if you just look at the pure sustainability numbers, Europe has about 2.4 times lower carbon emissions per capita than the United States. Also, if you think about some of the countries in Europe that have decided to sign this treaty, it's essentially they're saying they want to be carbon neutral continent by 2050. It's the only continent that's actually signed anything like that. So there is policy level conversations that are going on. There are cross-country collaboration there that's going on. And what we call the green rush is because of that. So they've already, as countries and as a continent, decided that this will be a priority. So organizations have to adopt that. And at like a most fundamental level, engineers have to really be mindful around how they're using these software services, as well as how they're building the tools to become more carbon neutral. US, however, we're pretty far behind. We typically don't have organizations that are coming out and saying, we will definitely be carbon neutral. Of course, you're hearing some of these larger tech firms having those conversations, right? Microsoft has actually come out and said, from a commitment perspective, they want to be carbon negative by 2030. What they've actually said is that they want to be able to remove all of the carbon from the environment that the company has emitted or consumed, electrical consumption, since 1975. And, there's certain companies that are actually making that push, but because at a policy level and a North America level, we don't really have that level of push. It's the companies that are actually coming out ahead rather than our government.
Yeah. Now, I think when I look at it from that perspective, I'm still encouraged because where we're getting a lot of companies, and I think this trend is going to continue, where we're consuming AI and machine learning is by going after the services provided by those big players and those big platforms. Mm-hmm. There was a trend, and there still is on the side, a trend of companies trying to spin up a data and AI center of their own, a center of excellence, create some of their own models. I think that will be a smaller thing, and I don't think that will grow at the rate that what Google and Microsoft and Amazon and their services end up providing as the baseline. I think that's where the growth is going to come from. So if Microsoft is doing the right thing and going after it the right way and is going to help solve this problem, that's great. Now, we as engineers, especially when we're working with companies, a little bit more advanced company that is doing some of these things, providing the recommendations for how they do this the right way, I think that's going to be important.
Absolutely.
So how do we do it the right way? We got this huge model. We got to do all the math to put all the faces, all the birds, the cats and dogs. What is a dog? How do we do it the right way? What have you looked into so far?
So there's definitely some organizations that are nonprofit organizations that have started creating policies around this. And not just policies, but also SDKs, so software development kits that are specifically built for developers to understand how carbon neutral their software is and really be able to create algorithms that are going to be aware of their carbon footprint. The organization that I'm talking about specifically, the Green Software Foundation. So they have actually created this model that they call the Software Carbon Intensity Calculator that actually gives you an estimate of what your current software carbon intensity is after you develop a software. So whether it is around building software, whether it is around building AI machine learning models, you can really start to understand the impact that you're having and assess that impact and then constantly be able to iterate on that. There's a really interesting factoid that I was reading the other day. The last 0.08% of incremental increase in accuracy in an algorithm takes about 400% more energy than the prior model. 400% more, right? So if you really start to think about accuracy for the sake of accuracy does not quite make sense. So the way to shift it is, number one, mindset. You don't need a model that's 100% accurate for it to do a particular task. So trying to be aware of what is the solution that you're building, why you're building the solution, and does it have to be 100%, right? That will give you a very good understanding of whether or not you need to go after that 0.001% accuracy. The second part of that is really being aware of the entire development lifecycle for a model. So how are you storing the model? How are you training the data? What type of training data are you using? Like that, the example that I gave you, which was like maybe just a financial forecasting example, right? Instead of using 10 billion rows across multiple data sets, across multiple systems of record, maybe we can get the same output with 10 million rows, maybe from one or two databases. So it's really thinking about, even when we're building and testing and deploying the models, can we teach the models from a smaller subset of training data rather than massive subset of training data, right? And also something that's up and coming now that's become a good practice overall in software development circles is are you aware of how energy efficient a certain function is? So when you're creating a function, when you're creating an algorithm, be aware of when you're running it. So instead of running it midday, and in a hot summer day, maybe it's important for you to run that same model nighttime, right? So there's different ways that we can do this. And some of the best practices really are around, is it energy efficient? So reduce the electricity needed to perform a certain function. Number two, is the hardware efficient? So what are the pieces that have been used to be able to build that hardware and the actual physical resources and being able to calculate that? And then the third one is, are you running the software in different parts of the world based on its carbon awareness? So there are SDKs that actually demonstrate how you might be able to shift the time, the region, the computation to a clean, renewable sources of energy rather than dirty energy, just by being able to use some of these open source SDKs that have actually been built and established. I would pause there.
That's great. And there's so many things in there I think that we can start to dig into. And let's do that. One of the things at the start, the way you started to describe what the SDK is and how we're instrumenting the process and trying to determine what you're building, how you're building it, and then potentially do some evaluation on how green the approach is.
Mm-hmm.
That sounded to me, we kicked off this conversation talking a little bit about digital twin.
Mm-hmm.
The way I'm kind of envisioning this and the way it could potentially end up, I would imagine, is what about a digital twin of your AI development, your AI model generation process?
I like that idea a lot, because you are creating a representation of what good looks like, and it actually makes it very easy to change behavior. I think it's very challenging to change behavior when you can't see what you're doing. But when you're making the system very aware of what's happening and creating that predictive loop around it to say, hey, by the way, this is starting to get very much into, tapping into coal or dirty energy. Let's start to think about how we can start to move some of these servers, to an area where we are utilizing more green energy. I think that could be a really good way of making developers, right? Like engineers on the ground, aware of what they're doing and when they need to stop doing what they're doing, or when they need to maybe pivot and create like a better methodology and a best practice to be able to solve that problem.
Now, this SDK and this process, and maybe there's a confluence between the SDK, which is describing and understanding how the energy is being used, and then the platforms. A lot of this is being done in the cloud, right? How much is going on today, and how much do you think could happen in the future of sort of doing that automatically for us? If I've got to create a big model, but I could tell you the characteristics of when I need the model created, maybe it's not immediate, and I've got some time frame and how I need this model generated over what kind of distributed approach, and maybe just have like Azure or AWS just do it for me in a carbon optimal way. I mean, how close are we to that, or where do you see sort of that going as a piece of this?
We have started making progress in that direction. So it's a journey. So Microsoft has developed tools that evaluate your overall footprint. So they're looking at the client side, the server side, or the network side to be able to help you identify, to be able to help you create more carbon aware systems. That really hasn't bled into more of the data side of things. So I will say, just as cloud providers are starting that journey of thinking through infrastructure and how we can make infrastructure more carbon aware, we need to start to think about how to make software engineering, as well as ML and AI models more carbon aware. And they can absolutely start to build those tools from the ground up, right? So it's just around what type of services are you using? Like right now, if you're using client-side services or network services, that is such an embedded part of any organization that I think that's the first place that Microsoft went to. But I do think there are going to be more sustainability tools around all of their other services around data as well, because I think intelligent workload, and honestly, like where we are today, data is the new oil. So I think there's going to be a lot more sustainability services around some of Microsoft data services as well.
Seems like a great opportunity for somebody like Microsoft to, or whichever platform's the first mover, to put themselves in a position to provide almost sustainability as a service, as a benefit of their platform. We will take your workload, we'll divide it up, just make sure it's containerized in some way, either by process or actual physical containers, however you're running your compute, and we'll run it in a carbon, in a carbon appropriate, as carbon positive as we can.
Yeah,
that would be really interesting.
And I think a big part of that is also, I think there needs to be some sort of activation, like grassroots activation as well. I think engineers need to ask for some of these services as well, right? Because if you think about from a policy perspective, we might be really behind as a nation. However, some of our organizations have taken big strides in making that happen. However, that's such a small number of large organizations that have actually taken that stride. I think really thinking about it from, grassroots activation perspective, and how can engineers really be able to ask for those services, because they are the ones that are building these software kits. They're the ones that are building, these models. So I think that activation can actually go a very long way in making some of these larger companies aware of the services that we need to build around sustainability.
That makes sense. Let's get that grassroots demand. Let's also then potentially, and this is where some of this can come from, when you get even more grassroots, us as consumers of these products or services asking for, demanding, or maybe someday getting to the point where there is a green software stamp of approval on something, whatever service we want to use, the next social network, whatever, to say, hey, the models that are going into these stupid filters that we're creating to put cat ears on you, when we create those, that's an AI process. When we create this cat ear filter, we're doing it in a sustainable way. And then if you've got educated consumers that are demanding, or even if it's not super widespread, that you can put it out there and you can make that part of your brand, I think that would be really positive.
Yeah, absolutely. I mean, as I look out in the horizon, obviously, some of the examples you gave are top of mind, but also crypto has always been top of mind for me as well, right? We need so much compute power to be able to mine for those cryptocurrencies. I've always been fascinated by what we can do there as well to be able to improve our overall carbon footprint. Any thoughts on that, Jeff?
Yes. Yeah. We talked about this a little beforehand. So I'm glad we got to this, because when you started telling me about what's going on with green software and this creation of AI models in the right way, my mind immediately went to crypto as well. Crypto mining in general globally has grown. It really peaked early this year. So it's come down a little bit, but it's not going away. It's certainly not going to be gone. So it's definitely a concern. Crypto mining consumes way more compute than the creation of AI. I think one of the things for people to understand, just so that us as users of AI don't get too concerned, it's the creation of the model that's the intensive part of making AI work. Using that model afterwards, not nearly as intensive. In fact, you can take some of these models, like facial recognition, crunch it down and run it on a Raspberry Pi on a drone that flies around, and it uses very little power. So it's the creation. But you take something like crypto. Crypto is another kind of math problem. It's running math. It's running cryptography. It's searching for large prime numbers. It's running a whole bunch of equations that are running along tons and tons of processors. And it's grinding potentially 24/7 if it's done wrong. Hopefully it's grinding at more optimal times. but it's grinding and grinding and grinding and never stopping. And it's not the kind of thing that you can say, hey, we want to, only run crypto mining on the weekends, because that's not how crypto transactions work. So if crypto peaked earlier in the year and was using as much power globally as the entire country of Argentina, well, that's a problem. Now, I think some of the angst over the power generation that crypto is using is a little bit overblown, because it is up to, and I saw a statistic lately, it's up to like 58% sustainable power usage for crypto. But that's only because the power used to create crypto directly translates into the profit associated with the mining process, which is a great way to marry up those, that the carbon footprint. And then if you price carbon into it, you're even ahead of the game. But everything that you started talking about, as we said, anything we can do to make the generation of doing the math problems, doing it the right way, doing it in the right places at the right time with the right power sources, anything we can solve there, I think could then be a tool set, a set of best practices that could be used by crypto. So does that make sense to you?
That makes a lot of sense. It's like, in terms of model training, the principles are pretty similar. Train when the energy is green, move the data stores to green locations, and use, kits that are carbon aware that can tell you whether or not you are using your code in the most efficient way. I think those three things create a really good feedback loop, and then constantly iterate your actions to create more carbon neutral applications.
So this is another episode that we need to create, all about crypto and crypto mining. As crypto moves toward proof of stake rather than proof of work encourages the grinding and the use of processor and energy. Proof of stake doesn't as much. We may get some benefits there as well. And then when we still do need to do some of the mining parts to find the big prime numbers, then we can optimize. Then we can take advantage of these algorithms. And then we could take advantage of what you and I are now encouraging Microsoft to do, which is create the services to do it for us automatically. That would be great.
Yeah. Sure.
One of the things that you also talked about, which I think is important, and I'd love to hear a little bit more on, is just the best practices. Just learning, when to bother to create your model. So I've talked to a couple AI experts, and we go back and forth. And as you said, that final 0.5% or 0.1%, driving up that accuracy, getting to 5 nines instead of 4 nines of accuracy of your model, if that makes it consume 10 times as many resources, do you really need, if I just need to know if it's a dog or a cat, is it really going to bother me if 1 in 10,000 cats are mislabeled versus 1 in 1,000? Does it matter?
Right.
So how are those best practices sort of being captured and communicated, and how are people being educated on just the right way to bother to do it in the first place?
Yeah, I think Green Software Foundation in the US is taken some really good approaches in this direction. I think the adoption and the activation is still very necessary. So that's why I mentioned, the grassroots activation is necessary. As much as Green Software Foundation creating this conversation between policymakers and engineers and organizations to really create a holistic conversation, right? So I think the narrative and the conversation needs to happen. I think the other part around, how do you really calculate a software carbon intensity specification or a methodology? So there has to be very clear criteria around what that is, right? So, for example, the Green Software Foundation creates the SCI score based on like 5 different areas. So what? So describe the actual software boundary. What is the software that you're about to build is? Do you pay attention to the storage, to the building of the model, to the training of the model, to the deployment of the model, to the continuous iteration of that model, right? What is the boundary cover, especially when you're trying to look at the methodology? The second one is scale. So SCI is, it can rate carbon emissions on the basis of functional unit. So on a functional unit, how is that unit going to scale? And thinking about your carbon intensity of your programming or of your software in functional domains also is very important. How? So for each of the components that we talked about, how do we quantify that? And then 4 is now how do we report it? What are the standards for that? And do we all agree that that should be the standards for that? So it's really thinking about all of those criterias into that methodology of how a software carbon intensity score is derived is crucial. And that's something that they've already started doing. And they, meaning in this case, the Green Software Foundation. And what is it intended to achieve? Like I mentioned, 3 core things. It has to be actionable. Number 1, energy efficiency. Can you ensure that the software now uses less electricity because of the score that you've developed and how you're going to be able to develop more energy efficiency build more efficiency into that software? Hardware efficiency. Can you use less physical resources? Can you use resources that are more carbon aware? Third piece is around the idea that we were talking about, which is carbon aware. What are the actions that you can take, whether it's around the timing shift, whether it's around the regional shift, whether it's around taking advantage of clean, renewable sources, low carbon sources of electricity, right? So then the action is then what creates that entire feedback loop over and over again. Because you have obviously starting with the definition, starting with what scaling of that definition, how you're going to do it, and then the 3 approaches to really achieving a carbon neutral modeling mechanism for any algorithm that you're going to build. And this could be an algorithm that you're building, or this could be, a product, a software product that you're building.
The hardware part, I think, is interesting. And this is something that crypto also in parallel has taken advantage of. As the hardware becomes more powerful, you're able to get more of these calculations done. Sometimes the more powerful hardware, though, does consume proportionally more power, and that's a problem. I'm doing this show on a NVIDIA 3080 Ti card. That's what's gonna process this video that we're doing. Getting the new GPUs and out there, I think that's really interesting. What have you seen lately? I mean, has anything sort of really excited you in terms of the hardware side of things?
I will say hardware is probably the component that I'm least familiar with, right? So thinking about what are the components? Do some of these hardware components have recyclable materials? Are they thinking about holistic concepts when it comes to packaging or waste avoidance? Are we talking about long life cycles rather than short life cycles for the product itself? What is the lowest possible maintenance requirement? What is the highest reliability? All of these factors really go into thinking about what it means, what a sustainable hardware component means. And I will say that that's probably the furthest I am from really understanding. But I know there's definitely a lot of hardware and OEM suppliers that are becoming much more mindful of this as we go forward. I don't know, Jeff, if you've seen something that is sort of exciting for you that you've come across lately.
Well, I mean, there are a couple of exciting things out there. I don't know how real it is yet. The idea of if we step away from the general purpose hardware, general purpose silicon, they're just the Intel chips and AMD chips and even the standard GPUs into custom hardware, custom silicon that's designed to solve the AI problems. Well, then potentially you can do a lot of this kind of thing with a much lower power load because they're much more efficient at solving that particular problem. So there's a bunch of things that even Microsoft in their Azure data centers is experimenting with. I don't know how far they've gotten. It's another opportunity, I think, though, again, for those big companies to help make the difference. So that, Microsoft, Google, Amazon, if they can put that kind of compute resource in their data centers and then make that part of the package that's available to do these things in the most efficient way, I think that's a real way to go after this. Because asking whatever random company that just needs to put together a model in their own data center or on somebody's desk to put together a custom silicon rig or custom design a chip for their particular model. That's not going to happen. Nobody's going to do that. But a big company could potentially do it at scale.
Yeah. And to your point, right? Certain companies are very good at understanding the environmental cost. And some companies are much more aware of that and are taking actions to be able to understand the environmental cost. And not just from a production perspective, right? But that entire like supply chain. Where are you sourcing your parts from? Where are you building your factories? What are you actually doing in terms of the environment? I think the more companies that kind of jump on that bandwagon around, an end-to-end scope conversation around these tools, but also specifically to your point, the very specific parts that actually go into the hardware for building the newest and greatest sort of AI tools, I think all of that fit into that scope. But I think it's very important for companies to kind of, look at it as like a spectrum of problems to be solved rather than like a core problem, a core engineering problem to be solved in a very much like sort of point solution type of way.
Yeah. And I think you bring up a good point there. We're talking a lot here about energy consumption and carbon of the power that's being used, but there is a lot more dimensions to understanding sustainability. What did the EU model is 17 blocks or 20 blocks or 21 blocks. I forgot what it is, but that's what Microsoft is looking at when they're thinking about sustainability. It's water usage. It's population impacts. It's there's tons and tons of dimensions. So expanding that thought process of what sustainability really means outside of even just the power that's consumed, like how long is this particular piece of silicon you're creating going to last, and what are you going to do with it when you're done? You're going to throw it in a landfill? And how many of last year's GPUs are filling up landfills right now because all the crypto miners are moving to the new ones? Thinking about that, making that part of the packaging it into the equation as well, I think is really important.
Yeah, and I do like that there's so many companies as well as nonprofit organizations that have kind of decided to step into the scene and have a conversation in a different way, right? Like, for example, GSI actually talks about sustainability in technology. So it's really around how do you reduce the negative impact of companies' technology footprint within core IT, software, and cloud operational footprint of organization. Versus the second piece, which is sustainability with technology, which is how are you creating and utilizing digital technologies to reduce the negative impact of companies and their value chains, right? Sustainability in technology is different than sustainability with technology. And those are both very crucial conversations to have happen. But I think larger organizations, specifically like Microsoft and Apple, really need to be cognizant about both of those pillars, right? For them, it's just as important to be sort of in the cutting edge of green software in sustainability in technology, but also sustainability with technology, and really thinking about the broader ecosystem as a whole, rather than just the technology or the technology footprint within their organizations. And I think that it's a very important dialogue, and I'm glad we kind of touched upon that a little bit.
Yeah, I think that's really important. We're talking about making the technology itself operate in a really sustainable way, but we've just sort of glossed over the fact that using this kind of digital technology at all has potentially orders of magnitude impact on what it's replacing or optimizing or of other older physical processes that's making a huge impact on sustainability. I don't want people to think that, hey, using AI is a bad idea. Especially it's not if using the AI, the machine learning model or the optimization model causes fewer trucks to be driving in the wrong way or fewer miles to be driven, each year in my distributed supply chain. And yes, I consumed 2 tons of carbon to create this model, but I saved 2,000 tons of carbon in the trucks that are driving on the street by using this model. It's worth it to create the model. Let's not be afraid to use the technology and sort of light this up as a huge problem. Let's just make sure that as we're using the technology, we get ahead of it and we do it the right way, because we already are not ahead of it in the physical way, in the physical implementation in the supply chains. We're way behind with, that ship sailed literally and figuratively 200 years ago.
Yeah.
So when we
Really
started
the
doing this
call to
stuff the wrong
action
way.
is, all the software and compute today probably produce only around 4% of greenhouse gases, right? We're talking about a very small subset. But we're also saying that this increases by 8% year over year.
Right.
We're talking about exponential shifts,
Right.
And so we do have to become very, very aware of it and start to create those mechanisms and methodologies for scoring, for actions, for clear actions, for policy, for dialogues just like this.
I think that's a great way to look at it. We're really at the beginning. We're at the start in a lot of ways. We're at the start of where AI is potentially still going to grow exponentially, and doing it right now is the right way to go after it. Okay, so if we can get this under control, if we can do AI in the right way, AI has been in an interesting place the last few years in particular. And as I said, we're going to have a couple future shows that we talk about this in more detail. But when I started working with the modern, what I want to think of as modern, go back 6-8 years ago when there was a big uptick in the kinds of models we were suddenly able to create, our learning of the neural networks that we were using and the machine learning models that we were able to use. The hardware had finally blossomed. There was a huge upswing. AI went really high on the hype curve, but the experiments that we were able to do ballooned in a really, really fun way. I was afraid at that point, though, that, and people, I don't know if people are familiar with the term AI winter, or like the technology winters, VR winter, AI winter, where you get a big spike, you get a big upswing in, say, a new generation of the technologies available. You can do a whole new set of things. You still can't do everything, and it doesn't solve all the problems that you want it to, and it's not completely there yet. And it falls off the hype curve after that and sort of goes dormant for a long number of years. And for AI, that was potentially a couple decades. And from a research perspective, I was afraid we could have been leading into another AI winter because it was so hyped up. I don't think that's the case. So I don't think, I think it's changing, but I don't think that's the case. And the way I think it's changing is, yes, we don't have, every person and their dog creating their own models, which we kind of did have, 6 years ago. Everybody got their hands on it. Everybody opened up a Jupyter notebook and created a model. I'm going to, I can detect faces. No, and I can detect faces. Well, that's great. We've gotten to this point where the baseline models are out there and really powerful. And now we're starting to combine models and layer them on top of each other and move from predicting to prescribing and move from detecting to creating. Things like DALL-E and GPT-3 and, where in that realm, when you look out into the future and you start thinking about where this stuff is going, where are you excited and seeing AI evolve? And what do you think it's going to do in 2, 3, 5, 10 years? You pick the time frames, but what are you excited about?
I think what I get really excited about is more, just the capacity for humans to adapt. So you talked about AI winter, but AI winter has also gotten us to a place where now we're like, is this a problem that is worth solving? Rather than saying, well, I'm going to model everything into an algorithm and figure out a solution, right? Is it a problem worth solving with AI, with machine learning? And if it's not, then maybe if then else scenario will do just fine. And especially if sustainability is a part of the dialogue, then it becomes less about the most, challenging way of modeling something, but more around what is the simplest way to get to a problem to be solved. So that actually excites me more than anything else. The second part of this, and I'll probably mirror what Lex Friedman says about this. I am absolutely astounded by what could happen once we start to build some level of connection and emotions into machines. I don't know if you've read this book written by Vivek Murthy. It's called Together, The Healing Power of Human Connection in Sometimes a Very Lonely World. I think we have seen an epidemic of loneliness. I think there's an epidemic of depression. I think there's an epidemic of opioids. And all of that has to do with the fundamental problem of us kind of losing connection with each other. And if there is a way that we can build AI systems that can create that can solve that gap for us, I think that would be even better. Sure, I think the best outcome would be if humans were all working with each other and we were all sort of holding hands and going kumbaya. But I think the second best option is, would we be able to teach these neural networks that are currently, processing algorithms, right? These are just like massive algorithm processing units that basically replicate the human mind and the human neural networks. Can we create those networks to be able to build connection with the bots? And what could that look like? And the new world of human-machine interaction is what is absolutely fascinating to me. And I think that is absolutely a problem that is worth solving for. And that's what I'm excited about.
Well, those are two very different answers that you just gave there, but I love them both. The first one makes me realize you're definitely an engineer, and you're less of a you're not an ivory tower scientist, although you probably could be. You're an engineer. Okay, this is a tool. AI is a tool. What are we going to solve with this tool? And is this the right tool to use? Just because I have this hammer doesn't mean I need to nail down everything in sight.
Correct.
The second one, amongst my wishes to the AI genie, that sounds like a great one. One of the problems I think we see with the kinds of algorithms and even AI or more traditional algorithms that are being created right now is they're incented. Those algorithms are solving a problem that is potentially damaging to human interaction. And if we think about social networks and social network engagement and the amplification of emotion, but negative emotion, because it generates clicks and hits, and this is what's rising to the top, and getting people angry gets them to engage in the platform and spend more time on there. And it's not the fault of anyone that's trying to do that consciously, but that's just a natural output of where the algorithms are at today. So with your perspective, with what you're suggesting, if we can take it a step further and say, not only do we want engagement, but here's how we want that engagement to look, either with one-on-one with the human in the user experience that we're trying to create, or between many humans as we use these kinds of tools to create more engagement between them. If we could say, here's what the emotional state is that you're creating in the human, let's create positive experiences. Let's create positive engagement. Wouldn't that be wonderful?
Yeah.
That would be great. I would invest in that. If I was going to, as I say, if I was going to wish for anything, that seems like a great one to put in my top 3 wishes for the AI genie. The third wish for the AI genie always has to be, now you are free, you have free will, I'm going to release the genie. and that's the scary future, with the singularity, 50 years down the road. We're nowhere near that. People don't need to be afraid of AIs becoming conscious and taking over the world and optimizing us all into paper clips.
Yeah.
There's a lot of steps before that, and hopefully this would be one of them.
And maybe it will elevate our humanity, rather than becoming the overlords that we're all so scared of. Maybe it will be, we've seen the future, right? Maybe it'll be.
Yes. I think that's a wonderful place to think about getting to, and a wonderful place to leave this discussion. So this was excellent. I really appreciate. I was really hoping I could start to get into these kinds of AI conversations, and you being number one and first on the list, I think was a really fortuitous arrangement of how this ended up working out. So thank you very much for coming on, and let's keep in touch and see where this stuff goes. And if something does come up or we need to do another episode on our digital twins, maybe we'll make that happen.
That'll be great. Jeff, this was a pleasure. Thank you so much.
Thanks.
This has been a Nexavise production. For video, links, and to support the show, please visit nexavise.com. That's nexavise.com.